study the preparation of colloidal sol. As we know that if we want to make a lyophilic sol, then no special method is need to be applied because the lyophilic sol can be directly prepared by the mixing of dispersed phase to the suitable dispersion medium. But if we want to form a lyophobic sol, then certain methods we have to use. So for the preparation of the lyophobic sol, we have to apply two methods we will study today: dispersion methods and condensation methods. So I have prepared two slides for you. Here are the methods which are called dispersion methods or disintegration methods. In these methods, we involve the breaking of bigger particles of the colloidal size, and this method is generally employed for this purpose are briefly discussed over here. The one is called mechanical disintegration. In this method we used mechanical mill, which are also called colloidal mill, in which we place the particular substances which have the larger size particles, that means the larger than the colloidal range size. And in this method we use mechanical mill, in which the two steel discs are present, in which we place the substance जिसका साइज बड़ा है और उसको इन मिल्स के बीच में क्रश करके आप कोलोइडल रेंज के साइज में ले आते हैं एंड देन यू कैन फॉर्म अ कोलोइडल सॉल्यूशन. सो इट इज कॉल्ड मैकेनिकल डिसइंटीग्रेशन. सेकेंड इज कॉल्ड electro disintegration. This method is generally used for the formation of colloidal sol of metals like gold, silver and platinum. And this method name is called Bredig arc method. It is an important method as a 1 mark question can come in your examination in such a manner. Name the method which is used for the preparation of gold sol, and the answer is Bredig arc method. In this method we will use this apparatus which is called Bredig method. In the outer chamber we are taking ice over here. In this chamber we will take water. Water means dispersion medium, and the two electrodes you can see are placed over here, and these electrodes are made up of the desired metal. Let us suppose you want to make a gold sol, then the electrodes should be made up of gold. Now an electric arc is struck between two metallic electrodes suspended in the water. The intense heat of the arc convert the metal into the vapors. When the electric arc is stuck in between these two electrodes, it will produce intense heat and the metal evaporate. But as the ice is present outside the chamber, the metal immediately condense, and the condensed drop just comes in the contact of the dispersion medium and they form the colloidal sol. So it is the method which is called electro disintegration method or Bredig arc method. The next is called peptization. It is a very important method for your board examination. In this method what we will do, a freshly prepared precipitate is converted to the colloidal particles by the addition of dispersion medium in the presence of a small amount of electrolyte. And this electrolyte is called peptizing agent. That means in this method what we will do, we will take a freshly prepared precipitate and then a suitable solvent which is a dispersion medium, add the particular PPT into the dispersion medium in the presence of a small amount of electrolyte, and this electrolyte is called peptizing agent. And the cause of peptization is what? As here we are taking an example of ferric hydroxide and we are taking the freshly prepared FeOH whole thrice PPT. Then we will add FeCl3 in that particular PPT. As you see that this FeOH whole thrice adsorb on the surface Fe+3 ions, that is the positive ion. So it will convert to the positive sol. Due to the presence of the same charge on all the molecules, that they repel each other and the precipitate will convert to the colloidal particles or to the colloidal sol. So it is called peptization. So peptization is the process of converting a fresh precipitate into colloidal particle by shaking it with dispersion medium in the presence of a small amount of a suitable electrolyte, and this electrolyte is called peptizing agent. So these methods are called dispersion methods or disintegration methods. Now we will study section B, that is the condensation methods. In the condensation or aggregation methods, we can use the following methods. The one is called biochemical reaction. So in the chemical reaction, first we will discuss over here by double decomposition. If we are taking H2S and it is passed through the arsenious oxide, then the H2S when passes through arsenious oxide, it will convert to the colloidal solution of arsenious sulfide by the process of double decomposition. Second is called bireduction. If we want to form the gold sol, then the gold chloride is treated or is reduced by SnCl2, and by the reduction process gold sol is formed. Next is called by oxidation method. If we want to prepare sulfur sol, then the H2S is passed through any of the oxidizing agent, as here we are taking the bromine water and H2S is passed through the bromine water, then sulfur sol is formed. We can also form the particular sol by exchange of solvent, as sulfur and phosphorus are soluble in alcohol. And when this alcohol solution of sulfur and phosphorus is poured into the water, then a colloidal sol of sulfur is prepared in the water. So it is called by exchange of solvent. Similarly, we can also form the particular sol by condensing vapors of any of the substance. For example, if mercury is condensed, then it can convert to the mercury sol. So these are the methods by which we can prepare a colloidal sol, and these are the condensation methods. Now we'll come to the next topic, that is purification of colloidal solution. That means if you want to remove the impurities present in the colloidal solution or then we can use these methods. The process of reducing the impurities of the electrolyte to the minimum required level is called purification of colloidal solution. So you can remove the excess of electrolyte by these methods. The first method we will study over here is called dialysis. The process of separating the particles of colloids from those of crystalloids by diffusion of the mixture through a parchment or an animal membrane is known as dialysis. As we have already discussed that colloidal particle cannot pass through the parchment paper or the animal membrane. So in the process of dialysis, we simply make a bag of the animal membrane and we will fill the colloidal solution which is impure in this bag, and we will just hang this bag. The excess of electrolyte as well as the crystalloid will come out from this bag, and the particular colloid in the pure state will remain here. So this is called dialysis. If in this process of dialysis we are using electrodes, then it is called electrodialysis, and the particular apparatus which is used for the dialysis is called dialyzer or the electrodialyzer. Now the second method is called ultrafiltration. As we know that the normal filter paper are permeable to the colloidal solution. So for the purification process, we cannot use the normal filter paper. So we have to use the ultra filter papers. And ultra filter papers or the filter papers can be made by treating ordinary filter paper with collodion. Now what is collodion? It is a 4% nitrocellulose with alcohol and ether. And after treating this particular ordinary filter paper with nitrocellulose with alcohol and ether, we dipped it into the formaldehyde, and then the pore size of the ordinary filter paper reduced. And these reduced size filter papers, which are called ultra filter papers, can be used for the purification of colloidal solution. When we filter the colloidal solution with this ultrafilter paper, that only the impurities and the excess electrolyte will come out, while the colloid solution will not filter. So it is called ultrafiltration. Next is called ultracentrifugation. For this purpose, we use an apparatus which is called ultracentrifuge. It is the method in which the impure solid is taken in the tube which is placed in the ultracentrifuge. It is a machine in which these tubes are rotated at very high speed. As a result, the colloidal particles settle down at the bottom of the tube, and while the other soluble impurities remain in the solution. Okay, so the colloidal particles have settled down in the bottom of the tube while the impurities remain in the solution. We can remove the impurities by decanting of the solution, and then rest part is the pure colloidal solution. So these are the methods by which we can purify a colloidal solution, and these methods are dialysis, ultrafiltration and ultracentrifugation. Now today we will discuss one more method, one more topic. It is the properties of colloidal solution. All the properties we will not discuss today, but let's start with some. First, we will start with the physical properties, and the first is heterogeneous character. As we all know that true solutions are homogeneous in nature, but colloids are heterogeneous, because we know that the size of the dispersed phase and dispersion medium particles are different. So, the colloidal particles are heterogeneous in nature. Second is called stability. Colloidal solutions are quite stable. Okay, so the colloidal solutions are normally stable, but they may be coagulate by certain physical changes. The next is called filtrability. We have already discussed that the colloidal particles can be filtered through the ordinary filter paper, but animal membrane or parchment paper does not allow the colloidal particle to pass through it. And actually these are the methods are used for the purification of the colloidal solution. So these are the properties. heterogeneous हैं, स्टेबल हैं और फिल्ट्रेबिलिटी इनकी है नॉर्मल फिल्टर पेपर से या ऑर्डिनरी फिल्टर पेपर से, मगर एनिमल मेम्ब्रेन या प्लांट मेम्ब्रेन या पार्चमेंट पेपर से आप इनको फिल्टर नहीं कर सकते. नेक्स्ट इज कॉल्ड ब्राउनियन मोमेंट. Colloidal particles show Brownian moment, and the Brownian moment is the zigzag movement of the colloidal particles. And the cause of Brownian moment is, it is based on the fact that the molecules of dispersion medium, due to their kinetic motion, strike to the colloidal particles, that is the particles of dispersed phase, from all the sides with different forces. and because of this reason the colloidal particles start zigzag motion, which is called Brownian movement, right? Next one is called colligative properties. As we know that colligative properties are the properties which depend upon the number of molecule. So if we are taking the true solution and we are taking the colloids, then we know that the particle size of colloid particles are larger than the true solution. So for in a particular volume, the number of colloidal particles will be less in comparison to the true solution particles. Okay, so the colligative properties values will be less in comparison to the true solution. Okay, so these are called some properties of the colloidal sol. In our next turn, we will continue with the topic, that is the properties of the colloidal sol. That's all for today.